one you asked about?
22.
Okay, so number 22 on the exam said that we have carbon-14 with a half-life. This is the way we write half-life for shorthand. Equals 5,730 years. And we have the number of carbon-14 remaining is equal to 1/8 the original amount. Number 22. And then it asks us, how old is the sample? So this is like the homework problem you had. You have 1/8 remaining. And so if it goes through one half-life, by definition, how much do you have remaining?
One half of the
One half-life, you have one half remaining.
2,865.
And so one half-life would result in n equals 1/2 n0. How much would you have remaining if it had gone through two half-lives? Okay, so I can't spell half or live.
1,432.
Okay, so you divided by 2 again, I presume. So it'd be 1/2 of 1/2, or 1/4 of the original amount. And if it goes through 3 half-lives, how much will be remaining?
716.
Okay, 1/8. And so we look at this and we say, aha, we have 1/8. And so that means it's gone through 3 half-lives, or it has 716 atoms remaining. And the question is, how old is the sample? So if it's gone through 3 half-lives, then its age is equal to 3 times the half-life.
Can't do that.
But did we actually talk about that in class? Like,
Yeah, we had a homework problem that did that.
Never mind.
my life!
Well, literally the past 2 weeks.
I think that's 17,190. I can now check the answer and see if that's one of them. Well, it says 17,200. 17,190 is the rounding of 17 or 17,200.
I still say that
So-
the question should be dropped.
Okay.
I do think that question should be dropped because I feel like probably all of us missed it.
I don't remember how many missed it.
What number I can tell you?
But I mean,
Yeah, I missed it.
you don't need to confirm to people what you missed.
I mean, I really don't care.
I am not grading out of the top score. Like I said, I've forgotten what I'm grading out of. I have it on my computer in my office, but I haven't uploaded the grades yet, and so you haven't seen that. And so I am discounting questions. I'm huh? Not on a curve. I'm scaling it. Right? There's a whole difference. If it's on a curve, you're going to have, like, with a class this size, at most 1A and 1F, and probably 1D and 1B, and everyone else is C. I don't think that that's fair. So I never curve.
Scale it.
Increase.
Yeah. I will scale it, which means I'm going to say, okay, I'm going to discount,
Question
3,
A.
4, whatever. Right.
But if you still got the
Hardly
question
anybody
right,
uses a curve because that forces everybody to be in the C's. In today's world, everyone would be upset if you all got C's, right? If there was at most 1A in the class with a class of 7, there's less than 50% chance there'd be anyone getting an A in the class if we did it on the curve.
But I mean, other kind of. I think there's like more than one type of curve, isn't there?
Well, when you say the curve, you mean a normal distribution, the bell curve. That's what the words mean.
Gonna curve it, they mean like not the back.
Yeah, they
Like,
don't mean
in a
curve it at all.
positive way.
They mean going to rescale. Okay, so reasons why I think this question is a fine question, just to justify why it's there. It is just like the homework problem, and the answer is years, that the number you were calculating, Hosanna, was the number of radioactive nuclei remaining, which would have a different unit. And so the units are a very important part of the answer.
Oh,
So, your number was a correct number for the answer, but not the one that was asked for.
What's the correct answer?
So the correct answer is this, which is rounded in your answers to 17,200.
Okay, but technically,
Yes.
I put none of the above, and technically, that is not a list of the answers, so I think I should get the point.
You did not put none of the above on any question you said.
Yeah, I did on the because I was so confused. Look at that, so I deserve the point.
Yeah, that was something I was confused about because I was like
10 years
wait,
off?
But I got it's like
That is
then
10 years is a long time. I could have a child in 10 years. I could have 3 children in 10 years.
And then,
I'm not like it's handy.
I'm not trying to be difficult at all here, but this goes to another thing that in science classes is important, and in other classes people don't even realize exists. And that is what's a meaningful number and what's a non-meaningful number. And
I'm just messing with you, Doctor.
I know, but I care about every student comment. I want.
We have a chemical change to our brains.
That number 5,730 years, that could mean two things. It could be it's somewhere between 5,725 years and 5,735 years, or it could mean 5,700. Well, between 5,729 and a half years and 5,730 and a half years. It could mean either one of those things. And we default to saying, since that 0 may or may not mean something, then it doesn't mean anything. So we default to saying that only has 3 digits of precision. So it could be different by as much as 10. And so when we do our calculation, we keep that same precision. So our answer would only be good to somewhere between 17,150 and 17,140 and 17,240. And so that's why we round it to the 17,200. So there's actually a scientific reason why that's the number given, but it's not something that we've emphasized at this level. Okay, any other test questions?
Yeah.
I want to address student concerns. Okay, question number 4. Question number 4 says, milk is an example of, and we talked about milk in the review lecture, and milk has these fatty globules in water. And when we have that, it's called a suspension.
Number 4.
Yeah. It's a suspension because you have one thing suspend the other. Remember I made the comment about the colloidal silver also being a suspension and talked about that. Other questions? Yeah.
Is there any way to look at our scantron?
At the actual thing you turned in,
Yeah.
I have them scanned, and so when I upload them, you'll be able to see that.
Because there's one question that I thought I said one thing, but the thing said so I was wondering.
Yeah, and check, and
But I'm
if
not
it's-
sure. I was like, well, I might have said this other one because I might have been debating.
if it's different, let me know.
But,
Because I know there was a thing I graded, it was different technology, but it had some of them marked differently, and so you gotta check. Yes, Hannah.
I don't want to bring my grade any lower, but there's some that I marked on here that are like saying I got them right, so I must have got mixed up on the Scantron. So my grade needs to be.
Okay, I'll look at your test, because I just did Scantrons and scan the test, so I have record of both.
Okay, because
So
there's
I'll-
definitely some that I marked wrong on here, but it says I got right. I'm thinking I got off on the Scantron numbers.
Okay, so I'll look.
Can we go over
Two in the same line.
Can we look at 21? Okay, number 21. Hydrogen sulfide, H2S, burns in the presence of oxygen to produce water and sulfur dioxide. Through this reaction, is sulfur oxidized or reduced? So this was something from the last lecture before the review lecture. Remember we had Leo, the lion says, and so we had lose electrons oxidation, gain electrons reduction. And then we had, what is the term oxidation? Where does it come from? If something gains an oxygen, then it's oxidized. If something loses an oxygen, then it's reduced. That's where the names oxidation and reduction come from. And so that's the way that's easiest to analyze this. I mean, you could use Leo, the line says GER, to do it. But it's easiest because in this case, we had this sulfur here gains oxygen. That's a 2, not a 4. Gains oxygen. So that's the definition of oxidized. It gained oxygen.
So if it gains oxygen, then wouldn't that be reduction?
No, that's the definition of oxidation. Oxidation is when it gains an oxygen. Because the oxygen is, for almost everything, pulling away electrons. I mean, obviously, fluorine would do it even more. But, fluorine and chlorine are stronger oxidizing agents than oxygen. But that's the one that they use for the naming. So if you wanted to use the Leo, the line says GER mnemonic, and analyze this, in this case here, which is more electronegative, sulfur or hydrogen? Sulfur. So that means that the sulfur has a net negative charge while the hydrogens have a net positive charge because sulfur is more electronegative. But then if you go over here, what's more electronegative, oxygen or sulfur? Oxygen, right? They're pretty close, but closer to than. And so in this case, the oxygens have the negative charge and sulfur has a positive. So the sulfur lost electrons, lose electrons, oxidation. So you could have looked at it either way. Obviously, the easier way was the one I started with, but the one that probably resonated with your thinking is this way, looking at what happens to the charge of the sulfur. Excuse me?
At least, after seeing that I did that, it's the weekend.
Oh, I thought you were saying at least after you see what you did wrong, you understand it. Because that would be my goal.
Back on a Monday, I don't know how I would get through the week. I would just cry.
Sorry.
Can we go over 39?
Am I wrong?
Over 39.
No, I agree.
Amber, we all need to be good.
39. The relative mass of carbon is 3/8 that of an oxygen molecule. How many grams of carbon are needed to have the same number of particles as found in 32 grams of oxygen? So this gives you essentially the math. You didn't have to look at the periodic table. It says the mass of carbon is equal to 3/8 the mass of oxygen. And so if that is for one atom or for 1 mole of atoms, Now it says how many grams of carbon are needed to have the same number of particles as 32 grams of oxygen. So if the mass of one atom of carbon is 3/8 the mass of one atom of oxygen, if I have enough atoms to have 32 grams of oxygen, that same number of atoms is going to have 3/8 the mass. So 32 divided by 8 is 4, times 3 is 12.
Here's your fortune.
What question was that?
That was number 39. Now, there's a long way of doing it as well.
I think that's the way I tried to do it.
The long way of doing it would be to say 32 grams of oxygen, which has 16 grams per mole, is equal to 2 moles. And then you'd say 2 moles of carbon, which is 12 grams per mole. Uh-oh. That gives me 24. How did I do this wrong? Or did they give me 24 is not an answer, so clearly that's not right. Oh, it's of an oxygen molecule. Okay, oxygen molecules have 32 grams. Oxygen atoms have 16. That's why it's. See, got to read it more carefully if you're going to do it that way.
So literally the way I figured it out was 3 divided by 8 is 0.375, and 12 divided by 32 is 0.375.
Right, that's this way.
Yeah. Well, writing it out really confuses me.
As long as it makes sense to you. Okay, there was one question everybody missed and nobody's asked about.
So you do know how to.
Wait,
I looked at it, I just don't remember most things. The number 41, I believe every single person missed number 41. A bombarding atomic nuclei with proton, quote, bullets in bombarding. The protons must be accelerated to high energies to make contact with the target nuclei. Why?
Because
So-
the target nuclei are positively charged.
Okay, the target nuclei are positively charged. Did you answer that?
No.
Okay, I was gonna say, no one got it right. That's the right answer.
Wait,
That's because
what
you can
number
look
are we
at
on?
see
what?
What?
Answer it. What it is, if it doesn't take.
Oh, she looked at that.
what is the correct answer?
Because the target nuclei are positively charged. To make the positive and the positive get close enough together, you have to have a high speed and a high
And the
temperature.
correct answer is B.
Okay, correct answer is D as in dog. Not B as in bog. D as in,
That was hard. I didn't need a question.
I think
Well,
you
got
should,
that
like,
wrong, I
take
guess.
30 questions off this test.
Yeah.
A little bit.
you what?
I think you should take 30 questions off this test.
I think you-
Question off is a little excessive.
I think you should take 41 out.
I think you
because
should
everyone
take
missed it.
10 out.
If you took 10 out, I understand.
Or 20.
There are only 46 questions. If I took out 41,
No, I meant like the number 41.
well, I am not taking out individual questions. I am just
I think.
So
grading
like,
out
there's
of
like a
X
curve,
number.
Or like what?
Well, as I said, I'm not going to do a curve. I'm going to scale it.
Oh.
That means I'm going to grade it out of like 39 or something like that.
Can you choose only the ones we got correct?
Yes. Yes, that's what I'm doing.
Oh.
Yeah, so that's why I was saying, like, you
So,
shouldn't count
We
41
did
as one of the graded
7
questions.
questions off.
Well, it actually wouldn't matter there because 41 no one got right. So whether I count everybody's score for 41 or not, it wouldn't make a difference as long as I lower the number. But the way I do it's like extra credit if you got one of the ones right. That
Oh, okay.
yes, Hannah.
Is there a way we can get extra credit in our test category
In the test category,
or quizzes?
What if
the extra credit I have set up is overall for the class, which would be more significant than in any subcategory.
Where's the extra credit at then?
Isn't extra
See,
credit
it's
is part of
for
The attendance.
helping with the demonstration in the lecture.
We haven't really done much.
No one has taken advantage of the extra credit opportunity yet.
What extra?
What? Like, what? I'm confused.
Well,
The,
how many,
the lecture assistants. I talked about in the first class about how to get extra credit in class.
but how would we like take advantage of it?
So you have to contact me and say, can I do the lecture assistance for this date? And then I look and probably I'll say, yeah, I got something perfect. We'll get together, we'll go over it for about a half hour. And then during the lecture, you have part of the presentation.
Oh.
What if we're not smart enough for that?
You're smart.
Oh,
Well, that's
so
how we
kind
did
of
like
like
a before class to set up demonstrations.
Well, and to go over how you're gonna,
Can
Do
that be a
Because I can't come to
like,
before class.
well, it doesn't have to be,
but we've only done a
it's
few
not gonna be
times.
the time period necessarily before. It's sometime in the 2 days before class.
Oh.
What do you say, huh?
We've only done a few demonstrations this entire year.
So when you say demonstration,
Like, what do you mean?
Few. Demonstrations like,
I volunteered to get myself shocked first.
yes, but we have to talk about it beforehand and you be prepared for your part of the presentation.
So to be fair, you actually never went over that we had to contact you ahead of time. You just said to volunteer in class.
True.
No.
And I did that.
I'm
She did it
pretty
too.
sure in the first lecture,
I mean,
I'll have to go back and listen to it, because that's kind of the.
I just thought it was the people to come up and set up the
Demonstration.
demonstration.
I don't.
So I don't know, I guess
I'll go back and re-listen to the first lecture, because I'm pretty sure it's funny.
So, like, if I say I want to help you on Monday, can I help you on Monday?
I'm sure you can, I have to look at the schedule, but if you want to do it Monday, we can do that, we have to get together sometime between now and class time on Monday to go for.
We'll get together now.
Okay, let's go for Wednesday.
Okay,
I
so you want to do that?
want extra credit, yo.
Okay, so we have to set up a time to meet, and I will,
So,
figure out what we'll do.
We'll meet after office hours because I go until like 5 o'clock straight every day.
let's just talk after class, okay?
I don't like to be late to my next class.
Well, we can email, we have lots of communication options, but I don't want to sit here and try to figure out the time that's gonna work in the middle of class time.
It's okay. Wait, do you have Snapchat?
Well, no, I don't have Snapchat. I just realized I opened the wrong lecture, though. I opened the water one instead of the rocks one. That's great. So let's open the right one. Okay, so geology. Yesterday we had our, come on, open up. We had our nature walk, if you will. Oh, okay, better have opened the right one here because that still says water. There we go. And hopefully you remember some things from it. So the geosphere is the name for, hey, it's just a funny word for our Earth, really. The geosphere. And 8 elements. How many elements do we have? This was a test question. Roughly
100.
Roughly 100.
this was a test question. No, it
Yeah,
wasn't.
what?
isn't it more than 100?
He said atoms instead of elements.
Oh,
Oh. Well, that's
Now,
why I got that one
If
wrong.
you look at it carefully, all of the ones that are black are naturally occurring. So we don't have 116 that naturally occur. We have, in fact, 90 that naturally occur, and the rest are synthesized. But of these 116 elements, 98% of the Earth is made out of just 8 of them. So we have trace amounts of the other things, the other 782. But primarily the Earth is made of iron, 1/3 of the Earth, iron. How do we know? It's calculated. What was that?
Is it in the mantle?
It's mostly in the mantle and core, yes. So that's why I said it's calculated. And then 29.8% oxygen. Good, lots of oxygen, we need that. 15.6% silicon, 13.9% magnesium. And then we have all the others. Notice carbon is not one of these. And yet we are carbon-based life forms. So the stuff that we're made out of is part of the other 1.9% of the earth. So when you look at this, well, one of the first things is why? Why do we have so much iron and oxygen, not so much of the other things? The best answer that scientists have is the conditions of the earth when it was formed. Now, there are different views on creationism. And some people believe that God created the solar system with adult, if you will, mature planets. And in that case, what I'm going to explain for the scientific explanation for why we have these as the primary elements doesn't make sense. The scientific explanation, unfortunately, I do not believe this, but scientists start with the premise that everything that has ever occurred has been natural, that there have been no miracles. So they start with the premise that there can't have been a creation. And so with that premise, we have a theory called the Big Bang Theory that says that, everything expanded from some magic that nobody can explain scientifically to create the universe, and our sun formed about 5 billion years ago, and the planets all formed with it. And because Earth is relatively close to the sun, the temperatures near the Earth when it was forming were high. And so things that have low melting temperatures and low vaporization temperatures, they couldn't stick together. Only things with high melting temperatures could stick together in the vicinity of where the Earth was formed. And so iron and silicon dioxide are two very high melting temperature things. And so that's why we believe these are the primary elements of the Earth. It's kind of an interesting explanation. Now, what does the Earth actually look like? We talked about this yesterday. The only part that we have ever been able to sample is the crust, the very outer edge. That crust, I forgot with this app, I can't zoom in as well. Compared with other things, that crust is pretty thin. So notice here it says continental crust somewhere between 30 and 40 kilometers thick. We live on continental crust. The oceanic crust might be as thin as 5 kilometers. I've seen 5 miles, 5 kilometers. They're obviously different. So it gets much thinner in the ocean. But I talked about yesterday density. And we're all floating, and things that are less dense will float lower, things that are more dense will float higher. That ocean has to essentially the same weight as the continental crust. So if it's thinner, it has the same weight, it's more dense. So that oceanic crust that's thin is more dense material. The continental crust that's thick is less dense, lower density. Which once again, it gets you a little confused because you think of the Earth as pretty dense. The rocks is pretty dense. But in the global scheme of the Earth, they're not. And so we're floating. Underneath this crust, we have the mantle, which has 2 sections here, the lower mantle and the upper mantle. So both of these tans are mantle. There is a difference in the upper and lower mantle that has to do with motion. This asthenosphere here is the region on which the crust, what we call the lithosphere actually, flows. So lithosphere, lots of new words here, right? We have crust, upper mantle, lower mantle, combined mantle. We have the molten core, the solid core, the asthenosphere, and the lithosphere. So I'm going to start with a careful definition on what the lithosphere is. Anybody heard of plate tectonics?
Yeah.
Okay, good. For those who haven't heard of plate tectonics, this is an idea that was invented around 110 years ago. And the idea is that the Earth is kind of like an egg with a cracked shell. So you have the mantle is the egg part. Okay, you better be a hard-boiled egg. The mantle is the egg part. I suppose the core then would be the yolk of the egg. And then the shell is the lithosphere. Lithosphere means the rock layer. So that rock layer is fractured like you crack the egg on the shell on a hard-boiled egg. But those little cracked pieces can now float around relative to each other. So those pieces move around and they slide against each other. And when they slide against each other, we have earthquakes. And there's lots of different pieces of this lithosphere where you have the boundaries of them, you have lots of earthquakes. So where do you have lots of earthquakes?
California.
California.
Fault line.
Okay, on fault lines. I was actually looking for the California answer, but
I know I read your mind, I got you.
yeah, all right.
That's the tectonics.
California is on the plate boundary. You guys may have heard things like someday Los Angeles California will fall into the ocean.
Yeah.
And someday Los Angeles and San Francisco will be neighbors. These are both statements about plate tectonics. We have a North American plate. That's the plate that we're on. It's like one piece of that fractured eggshell. And then we have the Pacific plate, another piece of the fractured eggshell. And those meet coming down the coast of Washington and going through parts of California. So part of California is technically already in the ocean. That is, it's on the Pacific plate, not in the North American plate. So they talk about California falling into the ocean. Well, that's already happened for places like Los Angeles. They're already part of the ocean. They're above water, but they're on the oceanic plate. And right now, that oceanic plate is moving north compared to the continental plate. So the Pacific plate is moving north, and the North American plate is staying put, relatively speaking. So that means that Los Angeles is slowly moving north toward San Francisco. So in a very, very long time, if that motion continues, the two would be neighbors. So that is plate tectonics. Now, California is what I expected people to answer because we live in the United States. If we were not in the United States, we might have answered somewhere like Chile, where they have more earthquakes than anywhere else on Earth. Why? Same thing, because they're on the boundary between plates. Now, we had the mention of faults, and these are going to come up again, but I want to talk about things while we're thinking about them. Faults are places where you have cracks in the lithosphere. If it's a really significant crack, then it's a plate boundary. But you have some that aren't all the way through that are still cracks. And when you have those cracks, you have stresses that build as you try to slide one past another. When the stress gets big enough, it slides, and that's when you have an earthquake. And so earthquakes occur on these faults when you have sliding at the faults.
Sometimes it's plates going
Okay?
away from each other as well.
Different types of motion. We're going to go really fast when we get to these because we're talking about it all now. We have the prime movers for all of this action is magma coming up. Magma means molten rock below the surface of the earth.
So lava.
Lava is above the surface of the earth.
Yes.
So it's magma until it comes out of the volcano, then it's lava.
Does the moon have any effect?
The moon does, yes.
Yeah.
But back to this. We have magma that's flowing up through the mantle, and when it gets to the lithosphere, what's the lithosphere again? It's crust plus the upper part of the mantle. When it gets there, it's pushing up, and because of convection currents, also goes outward. So the material is going like this. But that is taking the crust, the lithosphere on the surface, and pushing it apart. And so in the middle of oceans, we have rift zones. Rift zones, places where the magma is pushing up and then pushes the plates apart. And so that's a divergent boundary there, the one that Bryson actually mentioned. The plates are moving apart. But the surface of the Earth is a finite shape, right? It's size. It's not getting bigger. And so if the North American plate is being pushed, the Pacific plate is being pushed into the North American plate, then we're going to have something like this. And something has to give. Well, the ocean plate is more dense than the continental plate. So what happens when you have a more dense and a less dense thing? The less dense does what? Gives out. Well, it floats. And so when they come together, the oceanic plate is more dense and it slides underneath the North American plate. We call that subduction. Now that's not happening now, but it happened in the past. Right now, the plate is actually doing a rotational thing that's making it so it's sliding north. But in the past, that Pacific plate was sliding under the North American plate. Now, if I have rock sliding under rock, there's going to be some grinding. What happens when you rub your hands like this? Friction makes it get hotter. And so that's happening with the rock. So the rock is getting hotter until the rock melts. And when the rock melts, it expands. But what happens to density if something melts and expands? It goes down, which means that molten rock, less dense, floats up. And when that molten rock floats up to the surface, you have a volcano. So we have the ring of fire. We have all these volcanoes around where we've had subduction zones. It burns, yes. That ring of fire, yes. That has nothing to do with eating hot, spicy foods. So back to the topic at hand. Back to the topic at hand then. We have volcanoes occur where we have that subduction. So we can have convergent boundaries where one subducts under the other. We can have divergent boundaries where they move apart. Or we can have what's called strike slip. That's what's occurring between California and the Pacific Ocean right now. You're having a strike slip where it's sliding parallel to the crack.
Do
Question?
we need to know those different kinds of slopes?
Yes, and we will have them coming up again.
Okay.
We'll have them coming up again. I'll go through them quickly because we've already talked about them, but they will come up again. One last thing
One very last thing.
on plate tectonics for today. When you have two things come together, like let's say a Ford and a Mazda, what generally happens?
Crash.
They crash and then what happens?
Boom.
What happens to the cars?
They
Crash.
They can.
Condense.
Okay, they get crumpled. You have actually built-in crumple zones in your car so that energy, remember we talked about kinetic energy, energy will be absorbed in crumpling the metal. Well, the same is going to happen when you have this subduction. You're pushing on that continental plate, and the continental plate is going to do some crumbling, some crumpling. And we see those results very glamorously. In California, we have the coastal range, a range of mountains that were caused by crumpling where you have the subduction occurring.
I heard that's how the Rockies were formed, because west of the Rockies used to be an ocean.
It's not because West of the Rockies was an ocean per se, but that was going to be my punchline at the end of this thing. We have the coastal range, we have the Sierra Nevadas, you keep going in, you have the Rocky Mountains. All of those are believed to be because of the subduction of the Pacific plate under the North American plate. And so the Rocky Mountains was a weaker area in the crust where it crumpled. The Sierra Nevadas, a weaker area where it crumpled, and so on. All right. Now I've talked about, I haven't even talked about the, this way. Haven't even talked about the inner and outer cores, except for I did yesterday. So what do you remember from yesterday's talk about the inner and outer cores?
The inner core. I don't remember.
You get lighter as you go towards the core.
They are
That I did say that wasn't part of.
Isn't it solid?
One of them is solid. Which one? The inner core is solid. The outer one is molten. And a really great question is, how do we know one's solid and one's liquid?
We don't.
What we-
So it's the pressure.
We do for the same way that we can tell that there's a baby in a woman's, do you say fracking?
That's what I do.
Yeah.
That's what we do.
Yeah.
We frack. And then
No, Bryson, no.
But we don't look for oil.
Dude.
Not that far looking for oil though.
I know, but it's like, if they're like, that's what it's called when they send, like, sound waves into the earth.
No,
That's not
fracking is putting in hot steam.
Oh, okay, interesting.
but
Is that not what they-
we use the equivalent to ultrasound. We use seismic waves, which is what you were thinking.
Yes, that's what I was thinking.
So I should have a picture of that. This here is another picture of elements. What's different is this one is in the crust. So the crust is 46.6% oxygen, 27.7% silicon.
Still don't have any carbon.
75% is oxygen and silicon. That's because our silicate rocks, well, SiO2 to SiO4, depending on what you have, is the basic chemical formula. And so that's why those are the primary things. Once again, it goes to temperature when the earth was formed. Have to define minerals. Minerals, how many people take minerals for their health?
All of the-
Well, I mean supplements, not. Yeah. Yes, we all have some in our natural diet. Some minerals may be helpful, some clearly are not. Minerals, here is our definition. They're naturally occurring. They occur naturally. They're crystalline. What does it mean? Do you have a sense of what it means to be crystalline?
Kind of pattern was the
Okay, pattern. Very good. Crystalline means that you have the atoms in repeating positions. So pattern is a really good description of that. So minerals are crystalline solids. They're patterned. Examples of crystalline things. This is crystalline. It's aluminum. It's naturally occurring. It's mineral, right? They have an orderly repeating arrangement of atoms. That's what crystalline is. They have specific chemical composition with slight variations, and they're generally inorganic. Inorganic means not carbon-based. Now that's different than the organic and inorganic you use when you're buying foods. And I don't know how they got that definition for foods. It's supposed to mean natural or something like that in that sense, rather than what organic actually means. So generally not carbon containing. Classify these, and I was going to bring out the rocks, but obviously there's no point in it today. We'll bring out the rocks on Monday or maybe on Wednesday for Hannah to explain to everybody.
I love my life.
You should.
I don't.
You should. So our minerals are classified by the chemical composition and structure. So chemical composition, that's like, if it's I don't want to write something down and be stupid, so I will just leave here's the chemical formula for something, and we'll just leave it at that. That's sulfide, right? And the structure is the way the atoms are set up. So here's some pictures of some minerals. So quartz, I usually think of quartz as this clear one that you can see through. Rose quartz, why would this rose quartz have a different color? Yes, somebody crushed up the roses. Okay, that's not it. It has chemical impurities. This here, the milky quartz, it's possibly just because you have a lot of cracks and stuff in there. Or it could be chemical impurities as well. Another example here, hematite. Hematite is called hematite because it's got a reddish brown color. When you scratch it there, it kind of looks like blood. That's what the hema is. Well, iron is what the heme actually is, and our blood hemoglobin, because it has iron to give it its color. So hematite is a kind of mineral. Pyrite, what's the common name for pyrite? Fool's gold. When I was a kid, I was always looking for gold. Dad, is this gold? No. Is this gold? No. Is this gold? Because it has a luster like gold. Plagioclase and potassium feldspars, those are very, very common. These ones here are not so common. Calcite is very common. Notice the calcite here, they put some, okay, can't draw when I have it zoomed in. They put some acid on it and it's bubbling. So I'm going to have Hannah put some acid on a rock for you so you can see it bubbling. So we'll be able to use that. They use the acid test to see if it's something that is going to be calcite. And this last one, magnetite, is showing the nails because the nails are attracted to it. It's magnetic. We classify them with how hard they are, what their form is, their cleavage and fracture patterns. That is, on what angles can you split them, and what do they look like when you split them, their color and their density. Let's just keep going to, here's two minerals that are both made of pure carbon. Which of these would you prefer for your fiance to give you? The left one. The left one there is a diamond, but it's the same chemical as the right one, which is coal. Or actually it's graphite, but it's graphite. The difference in the two is their structure of how the atoms are held together. Yeah, we'll just stop here. We'll pick up on Monday.
Can you go
Question.
back to the slide that says chemical composition and chemical something?
This one? No. This one?
Yes.
Do you need my test to look at the Scantron?
No, I have copies of everything.
Left it.